Hello, everybody. Hope you're having a good day. So today we'll be doing the minimum distance of two words in a sentence. Given the strings text word 0 and word 1, return the smallest distance between any two occurrences of word 0 and word 1 in text, measured in a number of words in between. If either word 0 or word 1 does not appear in text, return -1. So the constraints are word 0 and word 1 are different, and we're going to be going through uh, a text that is of under 200k words. Okay, so the first thing we're going to do is to take care of the edge cases where word 0 and word 1 does not exist if word 0 not in text or word 1 not in text, return false. I mean -1. We might be able to remove that later, but we're gonna keep that there for now to simplify our problem. Okay, the next thing we're going to do is if we look through this example here, the text, dog, cat, hello, cat, dog, hello, cat, world. Word 0 is hello, and word 1 is world. And the output is 1 because there is only one word cat in between hello and world at the end. So there is two methods to do. I came up with two methods to do this. The first method, it requires O of n space. Well, they both require O of n space. It's just that this requires a little bit more space to store all the indexes of where word 0 and word 1 exist. So what I was planning to do, that I did first, was that I went through entire text and gathered all the indexes of where hello and world appeared. And then taking those two lists, I would go through an entire list and get the minimum distance between these two words. If I was smaller, it would increment I until then if word 0 index was less than word 1 index, then we'll keep moving the indexes forward. So that method is a little bit more cumbersome because it requires one more loop. So another method is that we're going to use just variables to hold the most current index. I think we can get away with just the most current index because we just want the closest items together, and by getting the most recent index we can search for the next closest item. Okay, so in that line of thought, I'm going to set the main distance, minimum distance, to equal to float of infinite. We can set it to 20k, 200k if we want, if they are that vastly far apart. Index is equal to -1, and so word 1 is index of -1. This is when we do not know the current index of these items. So for I and word in enumerate, text dot split. We're going to split the text by word. If word is equal to word 0, then we're going to set the word 0 dot index equal to I. Else if word is equal to word 1, word 1 index is equal to I. One thing to note is that we don't make any changes if nothing changes. So I think we should set this to be where we get the change our minimum distance. So min distance and absolute value of word 0 index minus word 1 index. Something to note is that we could write this once, but we would be running this multiple times here. So one more thing. Actually, we need to run this piece of code if a word 0 index is less than 1, doesn't equal to -1. We should skip this. Or if word 1, 0 is -1, we should skip this. Okay, otherwise we'll set the min distance here. And once that's complete, we'll return the minimum distance -1. Run it. Of course, the example set is runnable. And let's submit. And we have a 95.22, which is pretty fast. One thing we could speed up is to lose this right here. So we could return if min distance. Oh, actually, I think that speeds it up a lot, because that way we don't have to run through everything to get to the answer. What I mean is that if we do this check here earlier, so that we don't have to do all this work. But does this take a lot of work? I'm not sure. Well, we'll have to test it. Let's see. So if in this case, if min distance equal to float infinite, return -1. That's one way to do it. So let's knock this out here and run. Submit. It's slower. So going through the process is a little bit slower. So that was the fastest way to, at this point in time. I think that someone has a little bit faster, but I think this is the most straightforward way of solving this. We could simplify our code so that it doesn't look so corny, but it'll be a little bit slower. Let me do that. So what we do, pretty simple. Instead of these two loops here, we just do if word 0 equals -1, or word 1 index equals -1. We would continue, and otherwise we can set the min distance. Of course, this is updating unnecessarily, even though it's less code, because it simplifies the code. And run it. Submit. So a lot slower. The reason being we're computing the minimum distance value even when we don't need to. Well, I think that brings us near the end of the video, but I do want to think about this a little bit more. Can we clean up this code a little bit? Can we write a function maybe, or so yeah, I don't see anything. All right, well, thank you for staying with me, and if you have any questions, please comment below. If you have liked the video, please like, and if you want more videos, please subscribe. I think that's all, folks, and have a good one.